Hello, welcome to another lesson with Professor Checo. Pre-calculus for business. Today's lesson is finally the last chapter in 6.4. I'm very much ready to be over this topic. So let's just get straight to it and try to get it out of the way. And then we will have our third quiz will be posted containing chapters 5 and 6. So anticipate this to be quite a difficult one. I'm not going to say difficult. It's pretty straightforward. It's just very, you see, it's not the easiest thing in the world. All right, let's get straight into it. So let's go take a look at we got 15 questions, not too bad. Hopefully it's not that challenging. I already see an MM. All right, awesome. So let's go to the textbook. All right, so maximization and minimization with mixed problem constraints. So introducing the big M method. So we introduced the big M method through a simple maximization problem with mixed problem constraints. The key parts of the method be summarized. All right, so maximization. So consider the following. If I want to maximize this subject to that, to form an equation of the first inequality, we have to write the slack variable x1 plus x2 plus s1 is equal to 10. Got it. How can we form an equation out of the second equation? So then that would be minus, because it's obviously got that. I understand that. And then negative 2, because you're just bringing those over to solve for p. Okay, so it can be shown that the basic solution of system 2 is not feasible in any variable excluding p are negative. So a surplus variable is required to satisfy the non-negative constraint. The basic solution found by setting the non-basic variables x1, x2 equal to 0 is x1 equals 0, x2 equals 0, s1 equals 10, S2 equals negative 2, and then P is equal to 0. So to use this method, to use the simplex method on problems with mixed constraints, we turn to an engineered model of the artificial variable. The artificial variable is a variable introduced to the equation that is a surplus variable as to ensure an artificial variable is required to satisfy a non-negative constraint. Oh boy. So maximize this P, that minus MA. Now you have the problem. But where did MA come from? MA1 subject to this. The initial problem is this. Simplex tableau. The initial simplex tableau. Oh my goodness. This is with the pivot rows and all that. If any problem constraints have negative constraints on the right side, multiply both sides by negative 1 to obtain a constraint with a non-negative constraint. If the constraint is inequality, reverse the direction, introduce a slack variable with each negative. Introduce a surplus variable with everything bigger than that. Alright. This is just them working through it. This is them working through it. Yeah, I'm not gonna figure this out by doing it like this. So I got a minimization of this method. Is just, oh my goodness. Oh boy, oh boy, oh boy. Max. This is just all a bunch of, holy smokes. Alright, so like I said, the textbook really didn't help me, so let's try to figure this out. Alright, so introduce slack variables, artificial variables, and form the modified problem. This would be MA subscript 1. Where did it go? Where did it go? Which one of these did it go with? Did it go with 1? Plus A subscript 1, was that it? Plus 0, was that it? No. Is that an M? Oh, this is the original. Oh my god, I'm looking at the original over here. So I think this is negative, and then 18 is fine. Correct answers: A1, S1, A1. Alright, let's try to figure this out. So here, A1 was obvious. S1 is because it's less than, and we have to add S1 to both sides. And then it's negative when it's equal to. Alright, so let's try that again. Alright, so let's try. This is A subscript 1, S subscript 1 because it's less than, and then this is going to be minus A1, or was it MA1? Minus A1, A subscript 1? I already forgot. Minus MA script 1. Capital M. A1. Okay. Write the preliminary. 2, 1, 1, 0, 0. 1, 1, 0, 1, 0, 15. And then my solution is 4x1, 5. S1 should be 0. Negative capital M, and P is, oh, I gotta move these guys over, dang it. So this is a negative, this is a negative, this is a positive, and then P is 1 equals 0. At least one of your answers. No plus. 15, negative 4x1, negative 5x2, negative m, negative 4 should have been negative m. Negative m. Negative m, negative 4, negative m, negative 5. Holy smokes, where do these answers come from? Correct answers. Why is it negative minus? Negative 15m. How did that get to negative 15? Negative 4 minus m, negative m minus 4, negative 5 minus m, 0, 0, 1, negative 15. How do they get negative 15m from there? How is that negative 15m? I don't know where that came from. I don't know where they got the negative 15m from. I mean, finding the optimal solution is going to be a piece of cake because I'm just going to use the calculator, right? So find the optimal solution if the problem exists. So this shouldn't be hard. Let's see, we have 2 variables, 2 constraints. 2 variables, 2 constraints, generate the model. I want to maximize that. P is 4 and this is 5. My constraints are 2, 1 is less than 20, with this is 1, 1, equals 15. Solve. So my solution is 75 at 0, 15. 75. My profit is 75. X1 is 0. X2 is 15. S1 is 5. What is A1? Oh man. What's 5 times 15? 5 times 15 is 75, right? So if I were to plug in 15 into there, I have to subtract 0. Nice. Wow. Find the optimal solution with the original problem. I think this is going to be 75 occurs at 0, 15. I think so. Yep. Okay, so the only thing I don't know how they got. All right, let's try that one more time. Now that we think we got it. All right, so then this is going to be A subscript 1. This is going to be S subscript 1. And then this is going to be A subscript 1. Check. Okay. Then from there we have these. This is going to be 1, 0, P is 0, 40. This is 1, 1, 0, 1, 0 equals 30. This is going to be negative m minus 4. Let's try this as negative m. What did I just do? Negative m minus 5. S1 is 0. This one is 0. P is 1. And then I don't know what this is. I think this is maybe negative m minus 30. No. I don't know what this number is. I think I got everything else right. I just don't know what that number is. Negative 30m. I had everything else right, just not that. And the reason I got that, I just looked there. I don't have a reason. I don't have an understanding as to where I got that number from. Alright, so then, yeah, that explains that. You just find the optimal solution, plug it all in, boom, 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 and moving on. Okay. Next question. So let's introduce this. So here, I want to minimize. This should be A1 because there's an equal sign, A subscript 1. This is less than, so this should be S subscript 1. This is X1 plus that plus A1 because this is the equal sign, A subscript 1. And now the table is going to be 2, 1, 1, 0, 0, 1, 1, 0, 1, 0, 12. This one's going to be negative m minus 2. I think negative m minus 5. They gotta be capital? Yeah, probably. They probably gotta be capital. Capital M minus 5. What was this one? This one was 0. This one was 0. My profit was 1. And then what number goes here? Let's try negative 12m. I wish I understood why it was just a negative line right in front. I don't. Alright, and then from there, all I gotta do is plug this into my optimization and I get the answer. Moving on. Alright, we'll do it just to prove, right? Where am I? I'm right over here. Alright, so now over here I'm going to go maximize. I'm going to maximize 2, 5 to my constraints 2, 1 less than 16. And then here, this is 1, 1 equals 12. And then if I just hit solve, what do we got? We got minimum occurs at 60. Just close up a little bit. So we're going to go like that. We're going to go, the maximum occurs at 60 when x1 is 0, x2 is 0, no, x2 is 12, s1 is 4. Now let's check. If I plug into here, that's 60, so that means that a1 is equal to 0. Cool. Now find the max p. Oh, we said that it was at 0. No, this occurs at 60, 0, and 12. There we go. Okay, number 3. All right, introduce the slacks. So here, this is going to be p equals 4x1, 7x2 minus ma. And then it's 1, 1 plus 1, 0, 0 equals 4. Or is it minus? I think it's, no, it's plus. This one should be 2, 3, 0. Oh, it's greater than. No, it's greater than. So that's going to be should be -2, -3, 0, -1, 0, and that should be 14, where S1 is 0. I think I got something wrong here. No. Where did I mess up? Is S2 equal to 0? 0, and this is 1? No. -1? That's 0. I think A1 is going to be... Your answers are not correct. Where did I mess up? 4, 2, minus 1. 1, 1, 1, 0, 0. It was a +2, +3. But why was that one? Why did that one have... Alright. I had the right thinking. I just didn't know what to do with that A1. Okay. Complete the preliminary title. I mean, this is now just easy, right? Because this is going to be S1. I do 1, 2, 4, 1, 3, 7. S1 is 1, 0, 0. S2 is 0, -1, 0. A1 is 0, 1. This is going to be plus. This is going to be 0. This is going to be -m minus. This one's going to be -m minus. P is 1, and then that equals 0. P is 0, 0, and my solution should be 4, 14. What are the chances that's going to be correct? This one could be -14m. So let's check this. Let's try -14 capital M. P equals 4x minus, I don't know where I messed up. 1110004. I had that. 230 negative 11014. Yes. Ah, dang. A1 should be an M. P is 1, and that's 0. Oh my goodness. Okay. Alright, I understand what they're doing. I just don't get it. Alright, let's go continue. Complete the initial simplex. Complete the preliminary. So what's the difference between the and the initial? Is this the one where I had the answers? Let's try it. 1 1 1 0 0 0 4 2 3 2 3 0 negative 1 1 0 14, and then let's try negative m minus 4. Let's try negative m minus 7, and then let's try 0 0 0 1, maybe 0 here. No, so then let's try negative 14m. Two m, 3m. I see the numbers. The negative 2m, the negative 3. Why is this one an m? Oh my goodness. I don't understand where they get these guys. I just don't get it. I mean, this is the easy part. You just put it into the calculator to get the answers. To set it up, I just don't understand. Oh my goodness. So here I have two variables, two constraints. I want to maximize it, and it's going to be 4, and this is going to be 7. This is going to be 1 1 less than or equal to 4. This is going to be 2 3 greater than or equal to 14. Yeah, getting the answers not a problem. It's just I don't understand what to do with the first phrase. There is no optimal solution. Huh? What? What did I mess up? Maximize 4x1, 7x2, 1, 1 less than or equal to 4, 2, 3 greater than or equal to 14, where x1. Holy smokes. If this question didn't give me an optimal solution, then I don't know what it is. 04002 negative 2m plus 28. Oh my god. This topic is really not fun. So the maximum occurs at, let's try, negative 2m plus 28 when x1 is equal to 0 and x2 is equal to 4. that's where I got the answer from. Okay. Yeah, I'm trying my best to explain this. I really don't understand where this all came from. All right, so here we go. Let's do this one again. What's the next question? Edit the coefficients. I want to maximize and then minimize. So I want to minimize first. Find the optimal solution to minimize the problem where it's 2 and negative 10. This is going to be 1, 1 less than or equal to 20. And then this is going to be 5, 3 greater than or equal to 75. Solve that. The optimal is negative 110. Can I have negative solutions? All right, so I'm just going to type these answers in. Let's see if I can get it. Negative 110, where x1 is equal to 15 over 2 is 7.5, and 25 over 2 is 12.5. Okay. Now I'm going to go to the same exact thing. Let's go back to edit the edit coefficients, and let's just go maximize, solve. It should be the same answer, right? Because the minimization is equal to the maximization. No, it's not. 40, 20, 0. Maximum occurs at 40. This is going to be 20, and that one occurs at 0. Final check. Nice. Yeah, if we're solving it, it's really simple. All right, this one just says find the max. So this one has two variables, 3 constraints. Edit problem. 2 variables, 3 constraints. Generate the model. I want to maximize. So here, this is going to be 3. This is going to be 8. My constraints are 1, 2 less than or equal to 16. This is going to be 2, 1 less than or equal to 14, and then this is 1, 1 greater than 9. Solve. So now my minimum occurs, optimal solution is 62, 27000. So let's go, this occurs at 62, 62 with x equals to 2. That's 7. Yeah. Alright, so let's just talk about this. This is literally the same exact thing. This is literally the same exact thing. 3 variables, 3 constraints. You just plug it in. There's only one part. Use big M to find the maximum value. Alright, now here's where we're gonna. But this should just work. Like I should be able to just plug it in the calculator. New problem. What is this? This is 1, 2, 3 variables, 2 constraints. 3 variables, 2 constraints. Generate my model. I want to maximize 3, 5, 6 with constraint 1 being 2, 1, 2 less than or equal to 48. And then my second one is 2, 1, negative 2 less than or equal to 4. 4, and let's go solve. Adds. So here, 780 over 7. 780 over 7. 780 over 7. I'm just gonna put this over here just so I can like write it. This is 0. This one is 108 over 7, and then this one is 40 over 7. It doesn't say. I'm just gonna. That wasn't even close. Maximize 3x1, 5x2, 6x3. Subject to subject to, this should have been a 2. 2, 1, 2 is less than or equal to 48. 2, 1, negative 2. Now if I go to solve, I probably got the right answer. Let's see. Yep, 196, 0, 20, 0, 26, and 11. Yep, I typed it in wrong. Okay. So, same thing. Literally the same exact thing. 1, 2, 3, 3 variables, 3 constraints. Plug it into the calculator and you get it. Minimize one part, 1, 2 variables. Oh, this is 1, 2, 3 variables, 2 constraints. You add in the zeros. Let's knock this one out real quick. New problem. There are 3 variables, 2 constraints. Generate the model. I want to minimize 10, 26, and -5 with constraints 1, 3, 0, less than or equal to 4, and then this is 0, this would be 4, this would be 1 is less than or equal to 2. So here's my solution, -10, 0, 0, 2. So let's go -10, 0, -10, and that's going to be 0, 0, and the last answer occurs at 2. Yep. Okay. Same exact thing. Maximize it with 1, 2, 3 variables, 2 constraints. All right, here we go. So an advertising company wants to attract new customers by placing a total of at most 12 ads in 3 newspapers. Each ad in the Centennial costs $150 and will be read by 2,000 people. Each ad in the Journal costs $100 and will be read by 500 people. And each ad in the Tribune costs $50 and will be read by 1,000 people. The company wants at least 22,000 people to read its ads. At least. So that's greater than. And where does 12 come from? Oh, 12 ads. 12 ads, 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 and 3 paper. This is 150 x subscript 1. That's the cost, and it's going to be read by 2,000 people. And it's read by 2,000 people, 2,000 people. So that's going to be 2,000, 2, x subscript 1, and then it should be x subscript 1 plus x subscript 2 plus x subscript 3 has to be less than or equal to at most 12 ads, right? And then it's going to be 2,000 people are going to read x1 plus 500 people are going to read x2, followed by how many people? 1,000 people are going to read x subscript 3, and that needs to be greater than that. 150 x1 plus how much does the second one cost? $100 x subscript 2, and the last one is plus 50 x subscript 3. Yep, there we go. All right, now find the minimum cost and all that. So I'm just gonna go straight to the calculator, right? All right, so now here, new problem. Oh no, edit coefficients. These are 150, 100, and 50 with constraints 1, 1, and 1 must be less than or equal to 12 with 2, 1, 2, 3, 5, 1, 2, 3, and 1, 1, 2, 3. Oh, this is 5,000, not 500, is greater than or equal to 22, 1, 2, 3. There we go, move down. So the minimum cost would be 1,600 with 10 at first one and 2 at third one. So it's going to cost a minimum of 1,600 and is achieved by placing 10 in the first one, 0 in the second one, and then 2 in the third one. Cool. right? All right, a few more questions. So here, a farmer can use two types of plant food, mix A, mix B, mix C. The amounts of food in pounds of nitrogen, phosphoric acid, and potash in a cubic yard of each are given in the table. Tests performed on the soil that the soil needs at least 700 pounds of potash, and the test indicated no more than 600 pounds of phosphorus. So first for potash is going to be 16x subscript 1 plus 12x subscript 2 plus 16x subscript 3, and then phosphoric acid is going to be 12, 12, and 16. Can I just copy this? 12, 12, and 16? I can't. 12x subscript 1 plus 12x subscript 2 plus 16x subscript 3. And I need at least how many cubic yards of each mix should be added to the field in order to satisfy them? And maximize the amount of nitrogen. Oh, we gotta maximize. So that's 9x subscript 1 plus 12x subscript 2 plus 6x subscript 3 is what I'm trying to maximize. Cool. And then you just literally take this and plug it into our calculator. So this is 3 variables, 2 constraints. So this is going to be 9, 12, 6. Constraint 1 is going to be 16, 12, 16, 12, 12, 16. This is going to be greater than or equal to 700. This is going to be less than or equal to 600. Hit solve, close the add, and go to the bottom. There it is. So 675 over 2, which is, oh my god, what's 674 divided by 2? 337.5. So 337.5 by using 25 yards of cubic A and 75 divided by 4. What would that be? 72 is 19.5 and 0. 70 76. Oh, this is 75. No. 18.75. Is my number just off? Whoa, I'm way off. Where did I mess up? Did I type something wrong? Minimize. Oh, maximize. Yeah. That's annoying. 525. 25, 25, 0. Oh, there it is. Showed you. Told you. Alright, I got that one. Alright, so a refinery produces 2 grades of gasoline, regular and premium, by blending together 3 components, A, B, and C. Component A has an octane rating of 90 and costs $9 per barrel. Component B costs... Alright, so all this... How should the components be blended in order to maximize profit? So all we got to do is to maximize All right. The number of barrels of component A. So let's go -30 because that's costs. Number of using premium. Octane has component has an octane regular 90. Component B has an octane of 100. B is going to be -32, and C is going to cost -38. I can sell it. Regular gasoline sells for 40. Dang, what am I messing up? The total amount of component A used is x1 plus x2. What? 28x1 plus x2. I got it. I got it. I got it. So, maximize my profit. I want to maximize I think this is going to be regular sales for 40, and this is 48. This one is going to be 40 and 48. This one's going to be 40 and 48, maybe. P equals revenue minus C. What would it be? Final check. 10. Oh, because it costs 30, so I'm making a profit of that. It costs 32, I'm making a profit of that, and then it costs 38, so I'm making a profit of that. I got that. Okay. Okay. And then x1 plus x2 must be less than x1 plus x2. $35, 1, 2, 3. 10,000. What is this? 30, 1, 2, 3. 10, 1, 2, 3. And then they want at least 30, 1, 2, 3. And they want 20, 1, 2, 3. Oh, I could do that one. I have no idea what. x1 plus x3 is it 2, 2, x5, 2? I don't think these are all 2. Write the constraints that deal with the octane rating on the regular. Note that the octane rating of the blend is simply the proportional average of the two components. So proportional average should be is that gonna be 95 divided by 90 plus 100 plus 110? Let me just see if I get that one right. No. 5, negative 5, negative 15. I mean, I see that they're, you know, in like a reverse order, but I have no idea how they got their answers. Oh, well, I'm going to X out and let's just take a peek at the unit example. See if it has, oh my god, 20 parts. I got most of it. I just don't understand how they got those numbers for 5, 4. I have no idea where they got those numbers from, and they didn't really do a good job explaining that. I mean, it's somewhere in here, but distribute and then minus minus. Oh, they distributed my. Yeah, I'm not 100%. All right, look, I want one more. All right, so investors planning to divide our investments among high tech, blah blah blah, which is the one where we have to. Okay, so here we go. Boom, 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 boom. Construct a mathematical model in the form of linear programming. Use x1. The investor wants at least 20% of her investment to be in CDs and does not want the risk level to exceed 1.9. So it does not want it to exceed 1.9. So the risk factor, this is going to be x subscript 1 plus x subscript 2 plus x subscript 3 plus x subscript 4 plus x subscript 5. So let's see the risk factor, 2.8, oh, 2.8, x2 is 1.8, here it's going to be 1.1, this one's going to be 0.5, and then this one is going to be 0. Now, I want to maximize my profit, which is, I can't even copy all this, can I? Control copy, will accept it? Oh, I can. Now what are these numbers? 0.12, 0.1, 0.08, 0.07, and what is that? 0.04, 0.04. And here, like 20% of our investments to be 0.2. Subject to the risk level of each product is, and the percent of the total funds invested in that choice. The risk level for each product, for each choice, is the product of its risk level and the percentage of total funds. I also have to multiply these. Oh my goodness, I gotta multiply. I have to multiply that times that. I'm not 100% sure. I'm gonna do 0. I'm gonna do 0. I'm gonna do greater. Should be equal to. Should be at least 20% of her investment. At least 20%. X5, X subscript 5, and I think this is just this guy. X1 plus X2 plus X3 plus X4 plus X5 equals 1. And then X5 has to be greater than that. Oh, I got it. Right. Okay, okay. There it is. And that is the assignment. Wow, I'm so happy to be done with this maximization using this this method. That was a little over 50 minutes. Guys, honestly, best of luck.